Welcome, chemistry students, to the final installment in the covalent bonding chapter, where we are going to talk about the different forces of attraction between and within molecules during covalent bonding.
These forces between and within molecules can be categorized as either intramolecular forces, which would be the bonds that actually hold a molecule together, covalent bonds or ionic bonds, double covalent bonds. And then intermolecular forces are forces of attraction between different molecules that just happen to be near each other.
And this has a little bit different role in covalently bonded compounds than it does in ionic. We know there's those really strong forces of attraction in the ionic crystal lattice structure, which is why it has such high melting points. But here we're talking about the interactions that allow covalently bonded substances to be not just gases all the time, but to be liquids and even solids.
So when we talk about this, we want to talk about bond strength. And different bonds have different strengths. Now, the energy required to break the bond between those two atoms, we call that bond dissociation energy, which in turn is a reflection of the strength of the bond. If it has a higher energy to break that bond, it's going to be stronger than if it has a lower energy to break it. We measure that in kilojoules per mole, and we have a bond dissociation energy of 435 kilojoules per mole when I have two hydrogens bonded together, H2, that diatomic molecule. And if I have a single carbon-carbon bond, it has a 347 kilojoules per mole, so slightly lower bond dissociation energy.
Which would mean that that carbon-carbon bond is a little bit weaker, right, than the hydrogen bond.
But the big question is, why is there that difference? Why is the hydrogen-hydrogen bond stronger than the carbon-carbon bond? And I think if we go back to, or do we just want to leave that one out there? Why don't we just leave that question out there? And they can respond specifically to that question. See if they can explain that question in either your Moodle messages or your Moodle journal.
That is an excellent idea.
Okay.
You tell us why there's the difference.
So in intermolecular attractions, they're a little weaker, okay, those intermolecular forces, and weaker than ionic or covalent bonds. So it's not as full force as the bonds are. And we have two different kinds we're mainly going to talk about. Our van der Waals forces, which are named for Johann van der Waals. And this has two of our weakest forces involved in it. The dipole interaction between the polar molecules, so what those slightly positive or slightly negative polar ends, how they're interacting between different molecules, and also what we call dispersion forces, which are caused by the motion of the electrons and occur even between our non-polar molecules, so the movement of the electrons.
And you may know a little bit about this from your biology class or maybe your 9th grade science class, and it should make sense that polar molecules coming near each other, having a little bit positive and a little bit negative end, would have a somewhat stronger attraction between the molecules than, say, two nonpolar molecules coming near each other, which would only be attracted because of these dispersion forces, which means that the attraction's there and then it's gone. Then it can show up again, and then it's gone. That's a really simplified explanation of this.
As those electrons whip around the molecule, it's entirely possible for those electrons to kind of be on one side of the molecule for a fraction of a millisecond. And when that happens, that one side of that molecule is a little bit negative, and the other side is a little bit positive, just coincidentally. And that kind of has a ripple effect through that entire beaker of chemical with all those molecules in it. And for a moment, they're attracted to each other.
Our second type of our not second, but our another big intermolecular attraction is our hydrogen bonds. And this is actually our strongest intermolecular force. And it's actually a force, even though we say hydrogen bond, it's actually a force, not a bond.
It's such a strong force, we just go ahead and call it a bond, even though it's not.
And do you have a model there?
Here is a water molecule. There it is. The red is oxygen, of course. The white's hydrogen. And these guys, they're magnetized. Here, hold those up in front. The hydrogens are attracted to the oxygens, and those molecules stick together. They cling together like that, and that accounts for a lot of water's very weird properties. We've all seen insects walking across the water. How do they do that? Well, it almost appears as though there's a skin on the surface of the water. We call that surface tension. It's all of those water molecules that are at the surface are very strongly attracted to each other. Give me another weird property of water.
Well, how about the fact that it expands when it freezes?
Here you go. Clip those together.
So if we attach these model kits together, I know it might be kind of hard to see on a webcam, but they're trying to reach a hexagonal shape, and they're going to do that because of the two unshared pairs of electrons on each oxygen atom. And if we could imagine, I think it melted.
Yeah.
If we could imagine lots of these joining up together, we would get a crystal structure that we see for ice, and there's a hole in the middle of that, which is evidence of, at the atomic molecular level, of the expansion of water when it freezes.
And thank goodness it does expand when it freezes. Otherwise, every body of water, every winter, would freeze solid all the way from the bottom up, instead of forming that insulating layer of water across the top, so fish and frogs and whatnot can live through the winter underneath.
All right, thank you very much for watching. You'll probably need to do a little bit of investigation into these intermolecular forces. We know the names are kind of strange, but the process is really fairly straightforward. Remember to respond to your Moodle journal or Moodle video and with a 3 to 5 sentence summary and at least one question. And we're looking for that answer to that, what's the difference thing. We want to hear from you about